Okay, welcome to video blog about Java thread programming. Today I will guide you to implement very famous example about producer and consumer. So in this video I will guide you to understand about arrays and resource management using threads in Java. So first I define array here, array which have 1, 2, 3, 4, 5 elements. As initialize the array empty. Okay, and now producer is the person that produce a product, and consumer is the person that consume a product. Okay, so it means when producer produce a new product, so it puts into the first elements of the arrays. If it produce a second product, it's put into the second place and remains. After five product is produced, so we have 1, 2, 3, 4, 5, and the store is full. So we cannot produce a new product anymore because we don't have place to store. So now consumer can consume product. It consume one product, it get the first element. So it consume the second product, it get the second element. So now the store is free and it can boost a new product. And then producer will produce new product and push into the store E6 and 7. Okay, so why we need to implement this application? So you can learn about memory, about resource management in multi-threading application. It's very important. The second one is arrays in Java. Okay, and now I define three classes here: consumer, producer, and store. Okay, in store I define generic here because I want to store anything. We have methods insert t element. Okay, and then we have methods remove. Okay, and we have constructor to initialize the store. We have place to store the values with the array of t. Okay, equal new object. Default variables is 5 element. Okay. Then, so how can we know that the store is full? So we need to define a count values equal 0. So now define private count equals 0. Okay. Okay, now I define some getter, setter for getter values here. We just focus into methods here. Okay. The first is insert, the second one is remove. Insert new element into store. And remove an element from the store. Okay, so when I insert into store, I can use the count value here. You see, array count equal element. So I need to enrich count values. So I can do it in the same time by enrich assign first, then array later in the same line. Is it the same? Okay. It means we have this one and this one is the same. We can use this one or this one is the same. So I use the first one. So at this time, no problem. Okay, we can insert. So it means that we need to check if the count equal count from 0, count equal array dot length will row exception. Okay, and we define our exception. We return true new exception here, put a string star be full. Okay, now we can assign a new element. Okay, now we make producer at the address. And my element override the run methods. UI true. So I want to define the sleeping time for producer. I mean delays. And name also. So use super name for the name. This dot delays or delay. Okay, so I want to define getter setter here in run methods. So I produce a product. So I will push element to store. So I push store here, and this store I use integer. And so push store here. Star equal star. Okay, tester here. Okay, now we send a values, push new values in to the store. Insert. Okay, and we want to store the counter here to count the value number of product. First product is 1. Insert 1. Okay, and it's a proud try catch here without zero exception. That's okay. So after that we need to enrich the count values. So insert 1. After that, if exception, so I will spend in it. You see, and then I twice sleep. delay, another exception, interception. Okay, and now we can have run define main class for test. So define store here, store integer, define producer here, symbol Sunny, delay is 3 seconds, store above. Okay, and I run it. Okay, now we see the store is only 5 elements. The store only have 5 elements, so define the maximum value here. Okay. Now on the main methods, I run it. Sorry, I do not bring anything. So now I want to bring something. Push equal plus element into store. Okay. Run again. Oh, it's exception. I need to rule exception also. In the producer, we will bring exception here. Store is full. Push 1, 3 seconds for each one product. Push 2, push 3, push 4, push 5, okay, and push 6. Problem, store is full. You see, store is full, exception. This means that it can boost anymore. So it means that the store is full and the producer needs to stop sending new product. So then I define another address is consumer. And so override run methods. This run methods also define y true. Consumer also have name. Store okay, consumer computer so I want producer and consumer don't care about the data here. Oh, so I want to store value, so I need to define as integer. Okay, consumer also is store equals star. And so define getter setter methods here. Maybe it also has sleep with delays. Okay, and we consume star removes product. Consume a product. Okay. So get setter for delay here. Okay, you see we have star, producer, and consumer. Producer will produce a product, and consumer will consume a product. Okay. So we need to implement remove function here. Okay, so if it removes, so I need to remove from first element. So I cannot use count value here, so I need to define a new value. See our values. And out equals 0. Okay, this means at the first element, when the first element removes, so our value here, I'll stay in this line, in this element. The second consume, I'll stay here. Okay, I'll stay here. If they remove the task one, I'll play here. You see, I will define the position of remove item. Okay, out, and then you see I can remove I need to check if count equals 0, so it means I cannot remove anything. True exception. Star empty. Or we can remove our item from star. That's our position, and then as our position equal none. Okay, and I return item here. Okay, now I run remove. It need to catch exception. Okay, now I run. So I need to put a sleep in here. Delay. So now I define producer and consumer will process in the same store. So consumer also needs name also. Name delay install. Name win delay 1 second install. You see, a delay of producer is longer than delay of consumer. So what's happened? This means that the consumer will consume faster than producer. You see, consumer producer just push one element into store and store is full. Sorry, I check again. This cannot consume product. It's always consume null values. Equal 0 rule store empty. Okay, and the first time I don't insert value here. Store empty, correct. So it means when I remove, I should delete count values. You see, store empty because the speed of consumer is faster than producer, so the store is always empty. Rarely the consumer can consume a product. You see, product 3 and empty, and then product 4 empty, product 6 empty. This means that's very difficult for consumer to consume product. So now I increase the speed of producer. We go 500 milliseconds. No, for easy to look up, I use 2000. It means 2 seconds. BT for second. See, it's put a lot of items into store, but rarely user consume a product. So next the store will full. Problem happen. I know that it will happen. What is the problem? You see, when you insert a new values into the store, okay, when it has been guessed consume 1 2 3 and for inun 1 2 3 consume 1 2 3 and has been put 6 into store, put 7 into store, put 9 10. So because we did not check the index of insert, so I will bring out the store for you easy to look up. See again. One nun. You see, 2 noon. If it's habit consumed by 1 3, you see, 4 6 7 8. Problem this 1 2 1 has been consumed, so why 3 insert replay for 2. The problem because you insert use account values, so at the time we remove ones, it means that it just has one element in number 2. So if you just have number 1 is just have one product is true, so when you get count is written 1. So it means that if you put 3 in the 1 position here and it replaces 2, the problem happen. So therefore I should declare another values in values, and as first time in equal 0. In is a place that you insert the values. Example, this in stay here, and now in stay here, see, and now in stay here, see. In will indicate the place that you insert the new values into the store. Okay, in indicate the position of inserting. Okay, now I set the in value here, so I want to add a getter to avoid warning. So when I insert new values, I need to use in values, and then I recount values. Okay. When I remove elements, I just delete count value, but in value not delete. Okay. I run it again. See, 1 2 3 has been put in the correct place. 4 5, you see, and that's about section. 6 problem, you see, we put 5 into a new 5 position because we just have 5 elements. This means the maximum index is 4, so you cannot put to 5. The problem because we have none here, it means we still have one element can insert into the store, but the in values become 5. It's out of the arrays. It means that we need to run back in value here, return 0. Okay, so now if in equal size equals size, so it means that goes in equal 0 against you see 1 2 3 it consumed already 3 4 5 we found 6. Okay, 6 stay here. Em consume 6, you see none, em 7 8 9 10 11 store is full. The problem happened, so you see we consume a known product. We consume known product. Therefore, the remove function is incorrect because you see when you the R values become as our index. It means array our values have been not been increased. You see, so our value need to increase. You see, 2, 3, 4, 5. You see, 6 become at the first, 7, 8, 9, and 5 has been removed. Thanks, full, and it need to consume. Okay, store full. It cannot consume. What's the problem? You see, because our has been erased outside, so it means you need to measure our value come back the first element if it's written outside side of the array. So if out equal 0, okay, the same with in values. Null 3, 4, 5, 6. You see, 7 and it's consume some 5 also. 10 full. Oh no, it's consumed 6. So now full. It's consumed 7 and now it's full. It's consumed. You see, it's consumer is consume. No, sorry. The producer is produce a new product is faster than consumer. So you see a loss of full event. So I will change. I will make the consumer to consume faster. The producer will produce slower. You see, first is store empty. The product has been consumed already immediately after it's produced. Store empty, a loss event store empty here. You see. Okay. So how can I improve this cost? It means that our value here, we can enrich here, out equal out plus 1 molar for max values. Okay, plus 1 molar for max values. It means if we call max, it will return 0. Okay, and about the insert in value equal in plus 1 modulo max value here, and we remove it. Run again. You see, it's consumed. No problem. It's not good. Oh, because we entry in here, so remove it. Empty 2, consume 2, 3, consume 3, for consume for it consumes very fast. Okay, so why I made this video very long? You see, it's not a simple problem. It's a simple example, but not simple. So you need to understand what is resource management. To control your resource, you know, the resource is limits. Resource is limit. You need to control it well. If not, the system will be crashed. It's very important. So what is the resource? Memory, CPU, file. Okay, so you need to control your resource for better performance. So thank you for attention. See you in next video. This is the most difficult one. The other video will be easy. So thank you.